So this section of our chapter is all about chemical reactions. So the book that you are following, Cambridge book, you will have rates of a reaction, factors affecting rates of a reaction initially. So a brief talk about chemical reactions. What are chemical reactions? Chemical reactions are the process which are linked to chemical changes. So whenever a change takes place, the change can be either a physical change or a chemical change. A very easy example of physical changes: water changing from, say, liquid mode to freezing and you make it solid, that is ice, or you heat water and you make it to water vapor. The form changes, but chemically the substance remains the same, and interconversion of the form is very easy by usual methods of either changing the temperature or varying temperature. It's easy. No new substance is formed. Please listen to me and keep writing, okay? No new substance is formed in a physical change. Obviously the chapter is about chemical reaction. So when we talk about chemical reactions means they are representing chemical changes. So what is a chemical change? In a chemical change, new substance with new properties will be formed. A new substance with new properties, and usually you will not be able to reverse it by a normal process of, like, either say heating or cooling, the way you are doing it for say ice to water or water to ice or water to water vapor. That you won't be able to do in case of chemical reactions. And we have talked a lot about it, like new properties with new substance with new properties. Say for example, you have iron and you have sulfur on one side. You have, say, powdered iron and powdered sulfur. Now iron has magnetic properties, so if you mix iron and sulfur, well, if you mix iron and sulfur, no reaction takes place. Another thing to understand is that a reaction can be a very fast reaction, which is a spontaneous reaction, can be slow reaction, like say rusting of iron takes so much of time to form. Fast reactions are like explosive reaction, a bomb explosion, or say you are burning what you call butane, that is LPG. You're burning butane, that's a fast reaction. In order for every reaction to happen, something energy has to be required, that basic energy that you give. Now the reaction may be endothermic or exothermic, that's different. For example, let's say burning of coal to give you carbon dioxide. Now I can buy one bag of coal and keep it in my house. There is abundant oxygen which is present in the atmosphere. I don't expect the entire coal to burn down, but if the coal burns down, it will give me a lot of energy. But first we have to burn the coal, that is, you have to supply energy. So the minimum energy that you supply for a reaction to initiate is known as activation energy. Note down that point. Activation energy, we'll have a talk on this also. So the bare minimum of energy that you need to supply for a reaction to initiate, and then the reaction should have its own energy to sustain itself, or you have to keep on supplying energy from outside, because if the reaction has to go ahead. Now that depends upon whether the reaction is spontaneous or the reaction is non-spontaneous. That we will check later on. So what are chemical reactions? They represent processes of chemical change, new substances with new properties. So I go back to my example where I was saying that if I have iron powder and I have sulfur powder and I mix them together, now that's not a reaction. How do I get to know? Because you bring a magnet, you will still be able to attract all the iron fillings towards yourself. That means the parent property has not yet been lost. However, if you heat that mixture, a black lump forms which is known as iron sulfide. Now iron sulfide, if I put magnet on it, it does not attract at all. Another example is hydrogen and oxygen. Hydrogen being highly explosive, oxygen being a supporter of combustion, react together. Well, hydrogen and oxygen will just not react if you open two cylinders. Reaction happens under very other conditions, and then it forms water, which is a fire extinguisher. This chapter that we will be more interested to understand is, initially, how does a chemical reaction go ahead? What are the factors that govern chemical reaction? And how do we know what is the role of that particular factor? So before we start our discussion, we should first understand something called rate. Rate. What do we understand by rate? Rate means when you try to study the change in one quantity with respect to change in another quantity, that is called rate. Change of one quantity with respect to change in another quantity. Rate of change of distance is called speed. When speed changes with respect to time, when you change, distance changes with respect to time, you change time, how much distance? So that is known as speed. So similarly, the rate of change of displacement is known as velocity. So here we will be talking a lot about the rate of a reaction. Okay, as a common sense, what does rate of a reaction means? You would say, how fast does the reaction happen? Or how slow does the reaction happen? Now that is theoretical. How do you explain to me how fast or how slow does a reaction happen? Let's say, for example, I take a newly bought pack of Odonil, okay? And how does the Odonil come? You have a cardboard box inside which there is a foil sealed pack. We generally tear the foil sealed pack, and sometimes based on the amount of, the order that we want, we will either still retain a little bit of foil, or we take out the entire cake of Odonil and we put it back into the cardboard box, because you're not allowing all the oxygen or the air to come and react with it, because the faster the air reacts. Now, how do we know that Odonil is undergoing sublimation? It is from solid, it is changing to what? Gas. Now, how do we know the reaction is fast? If the Odonil cake keeps on reducing in its size very fast, then what do we say? That the reaction is going faster. Now, what is Odonil forming? It must be forming some sort of vapors which you are not able to see. If you would have been able to see the product also, then your perception changes. You would say, how quickly the products are forming is a measure of the reaction. Do you understand what I'm trying to talk? So when a reaction takes place, I have got reactants and I have got products. So how do I measure rate, which you will study in grade 11? So rate is the measure at which the reactants are either getting consumed, or rate is the measure at which the products are formed. Product formation is a positive rate, because as time progresses, more and more product will be formed. Whereas reactant consumption is a negative rate, because as time goes, the reactants are going to be used up. So in higher classes, you will study negative of reactants over time and positive of products over time. There is another way, see, because since I'm unable to use, if you look into it from a graph perspective, now try to make a graph. I'm asking you, try to make a graph. On your y-axis, just make a rough sketch. On your y-axis, you try to put concentration. You'll make two graphs, okay? Similarly, you draw two L's. Make two graphs, okay? And in both, on the y-axis, you write concentration. On one graph, you write it as concentration of reactants, and one you make concentration of products. Concentration of reactant and concentration of product. Have you understood? So we make two graphs, and on one side, on one graph on the y-axis, I've got concentration of product, concentration of reactant. On the x-axis for both the graph, please write time. Please write time. So I have made two graphs, right? Children, listen to me, because I won't be able to swap the board so much. So I have got two graphs with me. On one graph, on the y-axis, I have got concentration of product. On the other, I have got concentration of reactant, right? Reaction has started. Let us now see it from reactant perspective. Initially, when the reaction starts, do you have any product? No. We will have a lot of reactants. So we start from a higher point of the reactant. Are you understanding? If you look it from your side, then the graph is like this. So we start from a higher point of the reactant, and slowly as time progresses, the reactants are coming down. So you get a downward slope graph. If you are able to understand, okay, you will have a downward slope graph. Have you understood how a rational graph? Will you be able to trace that graph? Yeah, exactly same. You will have a downward slope graph. This is when you're observing it from the reactant side. And we expect that at some stage the reactant should be completely finished, or some reactants remain. That's why we have drawn a generic curve. But if we see the same graph from the respect of what? The product formation, then the product should go up. It will be an upward type. After some time, the product will become constant. Not, concave upward. After some time. Have you understood these two graphs? Okay, one of the graph tells you about how the product is formed, and one of the graph is going to tell you how the reactants are going to be finished up. Okay, if we try to convert, so either when we are observing two reactions and we want to say suppose there's a reaction A and a reaction B, and we want to say who is faster or who is slower, either you analyze A and B from the reactant perspective, or you analyze A and B from the product perspective. So rate means what? Rate means slope. If you see motion graphs, what is velocity? Velocity is rate of displacement over time. y data by x data. And you know slope. Just draw a tangent, you will be able to understand. So a graph which shows more slope will actually predict more rate of a reaction. And usually we will use the product graph. The product graph is easy because the product graph is going upwards. So if now, since you have a rate, a reactant graph and a product graph, forget the reactant graph and think only about the product graph and try to think product graph for 2-3 different reactions. Whichever reaction the product graph will have a more slope, that reaction is faster. That means in this reaction, products are forming very fast. So let's take our same example before we go to our content, that when I have that odonyl and I put the odonyl inside the cardboard and I say, Dhruv, that what you do, you take another odonyl and you just keep it exposed. In both the cases, here there will be a reactant loss case. Where the reactant loss will be more, the reactant will be lost where the odonyl is more exposed. So that in both cases, odonyl is changing from solid to its gaseous form, but the rate of the reaction is different. Our job today in this chapter is to understand that for a reaction, how can I make the rate faster or how can I make the rate slower, or what all parameters it affects. Are we fine? Yeah. So let's go one by one and see what is in store for us from the textbook. Okay, absolutely have your pencils with you, have things, because there's a lot of theory that will be coming in this chapter. Factors affecting the rate of reaction. Let us not mug up everything. The first thing we are talking about is the collision theory. We are not going at the factor at all. Collision factors are like some verticals. This is a factor, this is a factor, this is a factor, this is a factor. Later you will see in all these factors, one horizontal that is common is collision theory. Now let us understand what is collision theory. Okay, theory, but let us understand. So what we say that, okay, I have A as a reactant and B is a reactant, and I say A reacts with B. So far we have been very theoretical in our approach. A reacts with B. But what is happening in A and B? We have to go at a particle level. So we have particles of A. Now what particles? At a very microscopic, so you will say either atoms, okay, or molecules of A collide with molecules of B. There will be collisions. At the end of the day, the collisions will take place. And these collisions only will give me rise to the reaction that is going to happen. Say carbon and oxygen burns to give you carbon dioxide. At a particle level, carbon particles have to collide with oxygen particles. Every collision need not give you a reaction. We call them as unsuccessful collisions. And some collisions which will give me the reaction are called successful collisions. So please write down 3 words. You heard about, we're talking about the collision theory. And collision theory has nothing to do initially to understand these factors. Collision theory is like a horizontal. And later you will see that all our effort should be to support the collision theory. The more and more you support collision theory or you make the collision theory work in your favor, the reaction is going to get faster and faster. Understood? So in collision theory, I say that particles of the reactants collide with each other. So you can write particles of reactants collide. These collisions can be successful or unsuccessful. From what perspective? From the perspective of having a chemical reaction. So if the collisions result in chemical reaction, the collisions are known as successful. If they don't result in reactions, then they are known as unsuccessful reaction. Are we clear on this much or not? Okay. Now, based on the discussion so far, one thing is very much evident to us, that if we want a reaction to happen, we have to make the environment such that there should be a lot of collisions between the particles. Do you agree? Yeah. Okay. So when the collision, so what does the collision theory tell us? The collision theory says that the reactant particles need to collide with one another. For products to happen, certain amount of minimum energy will be required. Now let's say I have got coal in my house and I take some coal and I crush them and I make it powdered. Aren't there a lot of oxygen in my room? Yes, there is a lot of oxygen in my room. Why aren't the particles colliding then? Because if the particles collide, then reaction will take place. That is, carbon plus oxygen should give me carbon dioxide and coal should undergo combustion, right? So it is not happening because I have not provided the minimum energy required to initiate. So that is known as activation energy. Now look at this graph. You have energy on this vertical Y, and you have progress of the reaction. This is how the reaction is propagating. Initially, so when we say suppose a combustion or something, it will be that you'll be releasing a lot of energy, no doubt about that. But so we say enthalpy change of reaction, but the activation energy is the minimum energy. This much you have to first pump in, then only the reaction proceeds. So what did we learn so far? We learned that collision theory tells us that particles of the reactant should collide with each other in a manner that they make the chemical reaction happen. Such chemical reactions may happen from collisions which are known as successful, or may not happen. In that case, we call them unsuccessful. Now the question arises that if I give activation energy, are you guaranteeing, sir, that 100% of the particles will collide and give you reaction? Still no. Still no. Somebody may collide, somebody may not collide. We will see. There may be a proper orientation of collision is also important. Suppose the orientation was not proper, so that collision will not result to me. So have we understood collision theory? Now when you read about these parameters, one thing at your mind should always keep on striking: I have to facilitate collision theory. Then only my reaction will be faster. And if I do not facilitate collision theory, my reaction will be slower. Are we only interested in fast reactions? No. We might be interested to lower down the reaction rate also. Yes or no? So later on, we'll see if we want to expedite a reaction, what do we use? We use something called catalyst. If you want to slow down a reaction, we use something called inhibitor. Write down these words: catalyst and inhibitor. Catalyst will always speed up a reaction. These are the words that you are getting. So make a note of these. Catalyst is someone who speeds up a reaction. Inhibitor is someone who will slow down the reaction. Have you understood? A very nice example is digestion of food by the human body, which takes only 4 hours to digest. That's because you have enzymes in the form of salivary amylase in your mouth. If saliva was not there in your mouth, then the same digestion would have taken more than 20 odd hours. It would have been so nice. People would have eaten less, right? So let's go to the first thing, which is known as concentration of solution. Okay, we're going to talk about concentration of solution, and this is going with something called concentration, then collision theory, and then we need to read one more thing, which is known as the surface area factor. The surface area. Every aspect will be explained by an experiment. That means you need to understand the section very nice from ATP's perspective also, because you might get a question here from ATP angle also, right? So let's see this experiment, or let's discuss this experiment. It speaks about surface area. Let's see what is surface area all about. Do you understand what is surface area? So let me ask you, suppose I have a cuboid. So its surface area is the area of all the 6 surfaces. How to increase the surface area of the cuboid? How to, or let's say, let's have a very just unwrapped pack of dairy milk. That entire bar is there, or say a Kit Kat bar. You want to increase the surface area of the Kit Kat bar. Break it irregularly. The more you break it, the more surfaces get exposed. Now, if I say, if I break Kit Kat into more number of pieces, more surface area has been created. This is what children need to understand. One block of dairy milk, that is one square block, has a surface area. If the square block has been broken to more bits and pieces, the surface area increases. Your mind might not agree to it. You might be thinking, no sir, surface area of that big dairy milk was more. No, more amount of surface area has come out exposed now. Do you agree with me? So let's understand the impact of surface area with this particular example. Limestone. What is limestone? Calcium carbonate. Where is it found? Calcium carbonate is found in the form of limestone and also in eggshells. Keep these things as I'm speaking. Note down these things. It's also found in eggshells. And it is used for neutralizing soil acidity. Has nothing related to this chapter, but a very important line: soil acidity. If you find that your flower plants are suffering from acidity of soil, the easiest way you can protect is take some eggs. After you have made omelets, keep the eggshells, dry them, grind them in a mixer grinder, and put the powder on your flower plants. What are you making? You're making your soil basic. You're neutralizing the acidity. Okay? Now, powdered limestone is used as it neutralizes the acidity faster than if lumps of limestone were used. Wow, very nice thing. They started it with acidity of soil, and we will now see the reaction, what happens. So what is the reaction all about? Limestone reacting with acid. Limestone is basic, so it will reduce the acidity. But we are introducing limestone in two different forms, powdered as well as lump. Now, what did I say? What should you do for your flower plants? I said, dry the eggshells and make powder out of it and sprinkle the powder on your flower pot. That way, the neutralization effect will be far more faster than you just bringing one small rock of limestone and keeping it on your flower plant. Do you agree or not? Yes. So let's see this reaction. It says, in the laboratory, the reaction between acid and limestone in the form of lumps or powder can be observed in a simple test tube experiment. So a lot of ATP factors will come in. We will see them. Okay. So they have taken two test tubes. In one of the test tube, what they have done, they have put lump of what you call calcium carbonate, and one test tube has got powdered calcium carbonate. So let's see the reaction first. Calcium carbonate in solid form is reacting with hydrochloric acid. So write this reaction. A metal carbonate, whenever a metal carbonate reacts with acid, a metal carbonate reacts with acid, it will always give you a metal salt. Now, how is the metal salt formed? The metal cation reacts with the anion of the acid. Who was my metal out here? Calcium. Reacts with the anion of the acid. So what do you form? Calcium chloride. If this was sulfuric acid, it would form calcium sulfate. Sulfate. Understand? Metal carbonate reacts with sulfuric acid. So what will happen? The metal will take away the anion. So you get a metal salt. Carbon dioxide will be released. And your carbonate was CO3. Carbon dioxide goes out as what? CO2. You're still left with one oxygen. And the hydrogen of the acid was there. So they combine to form water. So will this reaction be there in your memory? Metal carbonate reacts with acid to always form a metal salt. Plus carbon dioxide will definitely come out. And water will come out. Right? Okay. Now let's talk about some characteristic of reaction. How do I know that with my naked eye that a reaction between this and this is taking place? So those characteristics you can just note down whether they are in your book or not. Characteristics of a reaction. This is different from factors. Okay. What does characteristic mean? That a reaction is taking place or not, with my naked eye, how do I get to know? First thing is evolution of gas. If by mixing two reactants or doing something with two reactants, you see the evolution of gas. Evolution of gas means, you understand? Gas coming out, effervescence, like this, or bubbling out. Then reaction is taking place. So evolution of gas. Second, you write formation of precipitate. Now, what is a precipitate? Precipitate is a substance that separates out from the solution and settles below. It will usually not get mixed no matter how much you stir it. Precipitate, understood? So formation of precipitate. These are things which you can observe from the naked eye. Change in color. Right, the third one, change in color. If there is a change in color, that means reaction is taking place. Change in temperature. That means endo-exo. You have learned about it. So either any of these four or a combination of these happening, I can always know that a chemical reaction is taking place. Now let's look at this reaction. How do I know a reaction is taking place? CO2. Formation of gas. So this will tell me whether reaction is taking place or not. So gas is coming out, reaction will take place. My interest is to find out whether the reaction is fast or slow, because I am carrying out the same reaction in two different forms. Now use your thinking process. How do I get to know about it? Is the rate at which CO2 will be formed. Yeah. Do you get it or not? So how do you get to know CO2 will be formed? Either you trap CO2, number one, which usually is a difficult process. And who is giving birth to CO2? You tell me from the reaction. Who is giving birth to CO2? Calcium carbonate. So if CO2 is getting formed, calcium carbonate mass should decrease. Or we can also measure that at what rate is the mass decreasing for either of the reaction. For what are you doing? You're taking a test tube, you have lump of calcium carbonate, you have powder calcium carbonate, you have put hydrochloric acid. Definitely there should be some mass of that particular test tube. Do you agree or not? Yeah. Now that test tube is releasing carbon dioxide. How is it releasing carbon dioxide? Because calcium carbonate must be disintegrating. That is, calcium carbonate's mass must be reducing. Whichever reaction actually shows me a more rapid rate of reduction in mass of calcium carbonate, that reaction is faster. Do you agree? Are you able to understand what I'm saying? So what should we do? We take a clock, okay? We take a stopwatch. We take, say, a funnel, or we take a, not funnel, we say a conical flask or a beaker, and in that we place the beaker on a measuring scale and put calcium carbonate in equal amount, one in the form of lump, one in the form of powder. Add equal amount of hydrochloric acid. Fair? Okay. And then start the clock. And then say every 1 minute. So immediately the reaction will start taking place. So the scales will now show reducing figures. Why? Because the mass of calcium carbonate is reducing. So you start noting down the mass of calcium carbonate, reduction in calcium carbonate at regular intervals for both the experiments, and then plot a graph. That should actually tell you the slope of those graphs. Will give you an idea about what is the rate of reaction and where it is fast or where it is slow. Have you understood, or do you want me to repeat this thing once again? Have you understood the idea? Or another would be that you start measuring the amount of CO2 that is formed. In that case, you are actually measuring the rate of product formation. In the former case, you are finding the rate of reactant being used up, and in another one, you are actually finding out the rate of product formation. So let's see what is happening. Okay. It says the rates at which the two reactions occur can be found by measuring either the volume of carbon dioxide that is produced, very good, or the loss in mass of the reaction mixture with time. What is the reaction mixture? Calcium carbonate with hydrochloric acid. These two methods are generally used for measuring the rate of a reaction, ATP type questions, for processes involving the formation of a gas as one of the product. Now what do? The apparatus shown is used to measure the loss in mass of the reaction mixture, the mass of the conical flask plus. So the conical flask will always be, this is the tare weight, right? It is constant in both. So you put them in both cases. They have put, look at here, out here it is showing 182.38, out here it is showing 183.62 as the reaction is progressing. Have you understood? As the reaction is progressing. Now they say, and you measure this mass at regular intervals, the total loss in mass is calculated for each reading of the balance and plotted against time. Some sample results are shown in a figure. We'll see the figure. Reaction between hydrochloric acid and limestone at its fastest is in the first minute. It's generally fastest in the first minute. Because in the first minute, everything is basic, everything is acidic, ready to collide. They're just ready to react. Okay. This is indicated by the slope, and the steeper the slope, the faster is the rate of reaction. You can see from the curves. So let us look at the curves now. Okay. Let's have a look at the curves. Just see. Loss in mass. Right. Let's have the two reactions. The first curve is telling me about lumps of limestone, and the next one is powdered. So if you see, in this much time, say the time is how much? In minute. In 1 minute, in the case of powdered limestone, we lost so much of mass. Whereas in 1 minute, when it was lumps, we lost only this much mass. So two graphs were obtained. Have you understood? It is the rate of loss. Now let us see the slope. How do you look at the slope? Draw a tangent to both the graph. Obviously, this graph has a more slope. बच्चा बैठाएंगे तो जोर से गिरेगा ना यहाँ पे. So it says if the surface area of the reactant is increased. Now what happened actually when you actually made the calcium carbonate in a crushed form. When you made it in a crushed form, you increase the surface area of the particles, right? Otherwise, what used to happen? Think it in a common way. In a lump, only the surfaces, particles at the periphery are having a chance to react. But when you crushed it, you made million particles, and all the million particles are having a gala time to get themselves drenched in hydrochloric acid. Do you agree or not? So as you increase the surface area, so we say if the surface area of a reactant is increased, more particles are exposed to the other reactant, more particle. And so the rate of the chemical reaction can be raised by increasing the surface area. Now go back to the other parameter that we studied. By increasing surface area, what did I do? I brought more particles. If particles are more, obviously the collision theory gets supported. Don't you agree? More will be the number of collisions. And if more is the number of collisions, the chances of having successful collisions are also very high. And every successful collision gives me a chemical reaction. So are you able to weave it now? The more is the surface area, the more are the number of particles. The more are the number of particles, the more is the collisions. More is the collision, more will be the chances for successful collisions, as a result of which my rate of the reaction enhances. So that's why we studied those two as a horizontal, like the collision theory as well as surface area. Further, now look here, how to understand the increase in surface area. We had a cube, we cut it into 3 different layers, so the surface area increases. Many people think, no sir, this is big. No, surface area has increased. You opened up, we had only 6 faces, now you have 18 faces. Then each is cut into 2 more. 36 faces have been now opened up. So the surface area has increased drastically. What type of questions I can expect is, I can expect MCQ questions, I can expect theory questions in the form of surface area and collision theory, and I can also expect a lot of ATP questions out from here. Plus some generic questions like acid reacting with the metal carbonate, and calcium carbonate is known to reduce acidity. So how does it reduce acidity? By reacting with the acid and forming carbon dioxide as a gas. Is this understood, children? And then this is the experiment that you are supposed to do in your school based on the same thing. Okay? Anyone has any doubt for whatever we have studied? Sorry, very sorry. Yeah. Anyone has any doubt for whatever we have studied so far? So far we studied about collision theory, we studied about what is the surface area impact, and we're going to study about, now we are going to study about what are the factors that affect the reaction, factors. So 2 things we have understood. Boy, if you want a reaction to happen fast, ensure that collisions are facilitated. How do you facilitate the collisions? By increasing the surface area. These 2 things should be in your head. Now we will see what are the factors that are going to actually help me in my quest of achieving more surface area and thereby facilitating the collision theory. Are we ready? So it says an increase in surface area. One more nice example. Do you know, when you take a chapati, it is made up of wheat, right? And we bake a chapati. Do you see the chapati getting burnt when catching flames? No, not necessarily, unless until you have been very, very careless about it. But if you know, if you take 2 or 3 granules of wheat and you just put it in the stove, you will immediately see explosive thing coming up. In movies and other things where you see some tantrics and other, they perform all this, the yagya and things. So how to excite? They will chant some other Om Im Jim Swaha aise marte hain. That is all basically wheat or anything. Maida is supposed to give you huge amount of explosion. If you have a lot of fire that is there and you take maida or wheat and you just put it, it will immediately create an explosion because the surface area is so much. But we feel that no, maida or atta cannot create any sort of explosion. That's what is written in your textbook. In Jamaica, in one of the wheat mill, some 3 or 4 sacks of wheat exploded, thereby killing 3 workers out there. Increasing surface area of a solid reactants results in an increase in the number of collision and this is results in an increase in the number of successful collision. Therefore, increase in surface area of limestone increases the rate of the reaction. If you are doing barbecue or if you are burning coal, sometimes if you take your forceps and if you just strike the piece of coal which is already glowing, you will see a lot of fire particles coming out. That's because now the coal has got shattered into small. That's why they say coal still can be controlled, but coal dust is very dangerous. If coal dust is sprayed, it will immediately explode. And that same phenomenon is actually shown by flour mills. So they say, for example, there's a risk of explosion in flour mills and mines. So you can get a question from here also, competency-based question. What is the risk of flour mills and mines? In mines, the dust can result in explosion. In fact, on 26 September 1988, 2 silos containing wheat exploded at Jamaica mill plant and thereby killing 3 workers at the site. Understood? Fine. Now let's test ourselves. What apparatus would you use to measure the rate of reaction of a limestone with dilute hydrochloric acid? What all apparatus you need? You need a measuring scale. I also need a stopwatch, without which you won't be able to do it. Following were the results obtained, so you can plot these results and thereby see which one is the fastest and where it. Clear? Now we go to factors affecting the rate of a reaction. Concentration. Let us put our common sense into it. Concentration. If you have something which is more concentrated, what does that happen? That the fraction of that particular component is more. Concentration more means that component is more. If the component is more, obviously its number of particles is also more. Okay. Now we have to again see how are you utilizing the concentration factor. Okay, you have, sir, I've got 1 kg of limestone. It means I will be able to generate a lot of carbon dioxide. Not necessarily. In what manner are you introducing those 1 kg of limestone also matters. So let's read about concentration. Now, this is a reaction in which I told you whenever a reaction happens, there are some characteristics. The first characteristic we saw was evolution of gas. Here we are seeing change in color as well as formation of precipitate. A yellow precipitate, that means color as well as precipitation we are seeing, is produced in the reaction between sodium thiosulfate. Thio word comes wherever sulfur is present. Sodium thiosulfate and hydrochloric acid. Just think yourself, what is sodium thiosulfate? A sort of salt. Metal sulfate reacts with an acid. So obviously the metal salt will be formed. Metal salt, the metal portion and the anion of the acid. Very easy if you actually put your head in the right thought process. So this is metal and its anion, metal salt. Thiosulfate means sulfur will be released. A gas will be released. In carbonate, we had the release of carbon dioxide. Here we are releasing sulfur dioxide. Sulfur dioxide, remember, is a harmful gas. We have read about it where in reactions of gases which used to come out from automobiles. Okay. And then we have water. The reaction is just similar to metal carbonate, only that you have sulfur production out here and sulfur dioxide instead of carbon dioxide. Now, it says the rate of this reaction can be followed by recording the time taken for a given amount of the yellow sulfur to be precipitate. Then the sulfur is always yellow in color and sulfur is going to precipitate out. That's why they have written solid. It will settle below. So what we do, we take a conical flask and we will put a cross symbol on a piece of, say, white background or a white paper, and on that we will keep the conical flask. What is the cross for the purpose of? The cross will tell me how fast the cross disappears from my eyesight is actually a direct measure of how much of precipitation and how much of color formation is taking place. If the color formation is fast, then the cross will disappear from my vision very quickly. Very interesting. Right. So they say the rate of this reaction can be followed by recording the time taken for a given amount of yellow sulfur to be precipitate. This can be done by placing the conical flask containing the reaction mixture onto a cross on a piece of paper. As the precipitate of sulfur forms, the cross is obscured. Obscured means something that goes out of your sight. Okay. And finally disappears from view. The time taken for this to occur is a measure of the rate of the reaction. So we are measuring the rate of the reaction by the formation of the rate of the precipitate, which is one of the product, and also the coloration. Agreed?
Yeah.
So similar reactions will also be taken out, and we will see what is the concentration based on the concentration. Now, how concentrated sodium thiosulfate, because we are studying the effect of concentration. To obtain sufficient information about the effect of changing the concentration of the reactants, several reactions of this type is carried out. Children, did you understand? The basic reaction says that if I have a mixture of sodium thiosulfate and hydrochloric acid, slowly what will happen? Sulfur will precipitate out, and this particular cross mark will start getting obscured Now I am studying what? Concentration. So what I will do, I will have such similar conical flasks, say label 1, 2, 3, 4 sample. First sample will have a particular concentration of sodium thiosulfate and hydrochloric acid. You can freeze one and vary the other. In the second one, I will have, say, a little bit more concentrated. In the third, I'll have a little bit more concentrated. Are you understanding? So more is the concentration, you will find that more is the reactant itself present. And if the say, which one should I vary? If I vary, say, hydrochloric acid's concentration is one of the best. Take dilute, less dilute, even less dilute, that is more concentrated. So more the acid is concentrated, the reaction will be much more faster. Is this understood? Okay, so let's see. What is the takeaway? Taking care as SO2 is released, again very important, which can cause breathing issues and asthmatic. So in this question, if a ATP type of question comes up and says, what are the precaution that you should take in this type of an experiment? This is a precaution part. SO2 means precaution. Nothing to do with this experiment, but it can come as a ATP question. What is the precaution and why? Some sample results of the experiment of this kind has been plotted in 7.9. So they have done some experiments, 7.9. And you can see from the graph that the most concentrated sodium thiosulfate was used. Now look at it. What does the graph read? Different concentrations of sodium thiosulfate, right? And then what did we do? And here they are saying time for the cross to disappear. Okay, time for the cross to disappear, and different concentrations. So let's have a quick look. So it says you can see from the graph that when the most concentrated sodium thiosulfate was used, the reaction was at its fastest, most concentrated. So it's 0.01, 0.015, 0.02, 0.02, 0.03. So if your concentration is increasing, the time for disappearing has reduced substantially. Able to interpret the graph now? Okay. So from the data that is shown in figure 7.9, it is possible to produce a different graph which directly shows the rate of a reaction against the concentration rather than the time taken for the reaction to occur against concentration. To this, the times can be converted to a rate. So rate is what? Rate is equal to 1 by reaction time. Understand what it says. It says that from the data in figure 7.9, it is possible to produce a different graph. So what they have done, rate is 1 upon reaction time. Why did they do 1 upon reaction time? Because if you do 1 upon reaction time, this graph now becomes, this graph flips. Did you see the beauty of it? With reaction time, the graph is like this. If I make a 1 upon reaction, the graph will flip up. So it makes it more easy for me to understand. And rate is always divided by time. So this is also divided by time. So in this graph, I get to understand very nicely. Now if you see, now what is my measurement criteria? My measurement criteria is the rate. What is rate? 1 upon reaction time. So I will now see if the concentration is high, the rate is very high, which means the reaction time is very less. Which means the reaction time is very less. I have nothing to do with reaction time, because at the end of the day, everything I want to listen in terms of rate. Right? So if the rate is high, when the reaction time is less, कम समय में वो reaction हो गया, तो उसका रिएक्शन स्पीड कैसा है? वेरी फास्ट. So you studied a lot of things. You studied about the collision theory, you studied about surface area, then you studied about the first parameter, which is called concentration. What is the impact of concentration? So what is the impact of concentration? At a higher concentration, the rate of a reaction is faster. And why does it become faster? Because more is the concentration, more will be the particles, and more will be the collision end of the day. And more is the collision, more is the successful collision, and more is the rate of a reaction. Right. Also, you studied about the characteristics of a reaction, that is evolution of gas, change in color, change in temperature, formation of precipitate. Clear? Okay. So it says, this portion is important. The products of a reaction are formed as a result of collision between the reactant particles. That is a Bible truth, you can't take it away. If products have been formed, the only procedure that have given rise to those products are collision, right? In a more concentrated solution, there are more particles, which leads to more frequent collisions. In our language, we will say successful collisions, which is between the reactant particles. The more often the particles collide, the greater the chance of them having sufficient energy to overcome the activation energy of the reaction, and so it is likely that a successful reaction occurs. Activation energy is given. Why? Because the particles are not colliding. Have you understood? If you have sufficient number of particles, then collision will automatically happen, or the chances of collisions are much more. And if the chances of collisions are much more, the need for the activation energy comes down. मेरा बच्चा खुद से पढ़ता है, रोज रोज बोलने की जरूरत नहीं. Please study, I will give you this, I will give you that. Not required. This means that the rate of the chemical reaction will increase if the concentration of the reactant is increased, because there is more particles per unit volume. Please note this, more particles per unit volume, Sometimes pick the right choice, they may ask this. Okay, let's discuss about pressure, not even reading at it. If you have a gaseous reaction, gases can exert pressure only when the gas is trapped in a container. खोल दोगे तो उसका गैस का प्रेशर थोड़ी रहेगा. What is pressure? Pressure is created by continuous. Let us first understand what is pressure. Pressure is given. Particles of matter are continuously in motion. If you are in gas, the motion is very high. And if you are in a container, that particular particle is every time going and knocking at the walls of the container. So I take one finger and I poke on my, say, tummy. So initially you will laugh, you will have tickling sensation. If this poking increases its frequency, I feel discomfort. And if I make it faster, I don't recollect a moment when the finger was away from my skin. Very fast. So I feel that continuously there is something which is pressed against my tummy. Is it causing me pain? Yes. So it's a force. The pressure has given rise to force. So this is pressure. This is gas pressure. Particles striking continuously at the walls, and the strike is so fast that there is a continuous pressure. So for pressure to come, I have to enclose the gas in a container. Well, I have enclosed the gas in a container. Now if I increase the pressure, which is something like, say, a syringe, if you increase the pressure, then do you think the collisions will be more or less? Much more. So if you increase the pressure, the rate of reaction will be faster, because you are facilitating the collision. And this is what we will be studying in the formation of ammonia. Ammonia formation and equilibrium, when we discuss, we will be studying this. Certain reactions, gaseous reactions, will occur always much more when the pressure is increased. So in reactions involving only gases, mind you, only gases, an increase in the overall pressure at which the reaction is carried out increases the rate of the reaction. The increase in pressure results in the gas particles being pushed closer to each other, increasing the number of particles per unit volume. In another sense, it is what? Concentration. Increasing the number of particles per unit volume means increasing the concentration. The more I apply pressure, the more number of particles will be now coming in contact with each other, because I am reducing the free space. So number of particles per unit volume increases. As a result, collision theory is facilitated. So number of collision will increase, and the rate of the reaction increases. Have we understood this? Okay. Let's talk about temperature even without reading at it. Let's look at temperature. What happens? Let's take gases. If you enclose the gases in a container, what did you understand? That if the pressure increases, the reaction goes up. Now forget about the pressure. You start heating the gas. If you heat the gas, don't you think that the gas particles will gain more kinetic energy? More is the kinetic energy, more they will move. More they will move means more is the knocking. More is the knocking means more is the collisions. And so more is the reaction. When a particular food material gets stale, that is also a chemical reaction. See, so interesting. Listen to me. A food particle getting stale is basically a chemical reaction. That means collision, when collisions are more, the reaction happens faster. That's why you keep it in the refrigerator. You are reducing the temperature. So the chances of collisions have come down. So the chances of reaction also comes down. So we read it. It says, what do you think? Why do you think food is stored in a refrigerator? The reason is that the rate of decay of food is slower at lower temperature. We always know what happens at higher temperature. See, why does cooked food get spoiled? Let us understand this also. This is called rancidity. What is it called? Rancidity. R-A-N-C-I-D-I-T-Y. Rancidity is the oxidation of food. There are two types of foods. Oily foods, like say paneer butter masala, chicken butter masala. These are very oily foods. All oily foods are highly prone for oxidation. That's why when caterers make oily foods for large parties and caterings, they will add something called antioxidants. The antioxidants we generally have in market will have two chemicals, BHA, BHT, butylated hydroxyanisole and butylated hydroxytoluene. Not for your importance, just understand. They will add that antioxidant because have you seen the guy who is giving you paneer butter masala? He will always try to serve from one end. Our parents also tell us, don't try taking oily food from all sides. The food will get spoiled much more quickly. Try to cut it from one side. And once his serving dish is over, one guy will come and again empty some more chicken, mutton or whatever into it. So the chances of getting spoiled is very high. So they use antioxidants. Otherwise, let's see another things like say chips and other particle things. So you have to delay the oxidation. So how do you delay the oxidation? Cut off the oxygen. How do you cut off the oxygen? Airtight containers, nitrogen packaging, or you put it inside refrigerator. If you don't put in refrigerator, then there's something called anaerobic and aerobic respiration, bacteria. The bacteria are going to make the food stale. So in low temperature, the bacteria are very ineffective. And why is the bacteria ineffective? Because the oxidation rate is less. And if we marry with this particular thought process, then we say that the rate of collision is much more less. Makes it understand much more easy. Okay. So we say that the reason is that the rate of decay of food is slower at lower temperatures. This is a general feature of majority of the chemical processes. Reaction between sodium thiosulfate and hydrochloric acid. Where sodium thiosulfate and hydrochloric acid. Children, where did we study it? We studied it for the rate at which the cross disappeared from our eyes. That was a colored precipitate. Okay. Hydrochloric acid can be used to study the effect of temperature on the rate of a reaction. Now look here. Look. The same reaction they are going to now study it from temperature. Figure 7.11, which is the figure that is enclosed out here, shows some sample results of the experiment with sodium thiosulfate and hydrochloric acid. Okay. Forget this reaction. Do we use acids to sometimes clean our toilets, bathroom and all these things? If you have got little bit, it's just a common sense that if you have more stubborn stains or something like that in your bathroom and all, you will take the acid water, and if you use some more geyser water into it, some hot water, the dirt gets removed much more quickly. Hot water. So what is hot water doing? It is further expediting the rate of the reaction. So if you look at from particle theory, particles to collide should have kinetic energy. So you gave surface area, I agree. You gave concentration, I agree. You are now giving additional energy also so that the particles keep on colliding from various angles. Don't you think the reaction rate should be faster? The same thing is written out here. So they have used the same mixture of sodium thiosulfate and hydrochloric acid and they have seen it at carried out at different temperature. You see from the graph that the rate of reaction is fastest. Now time, observe again, Dhruv, this reaction is between time and temperature. So we will see a rational graph. If we try to plot it against 1 upon time, that is rate, then it will go faster. So if you see, when the temperature is high, the time for the cross to disappear has come down significantly. Clear?
Yes.
So let's read this. As the temperature increases, the reactant particles increase their kinetic energy. Children, these are all basic stuff, but just don't mess up on these keywords. Some of the particles will have an energy greater than the activation energy. This is what you should inform at your grade level. You just can't say that their kinetic energy increases. So what? So what? We know that for the reaction to initiate, the activation energy demand has to be met. So you gave it energy from outside. So some of them gained energy enough greater than the active. And once activation energy barrier has been crossed, we call it the threshold barrier. Once that barrier has been crossed, the reaction will automatically initiate. So it says that they move faster and the movement results in more frequent collision. Some extra collisions that result from the temperature will be also successful. So some collisions which you felt were unsuccessful now get turned into successful. Your convert ratio is very high. Concentration say successful to hoga. Then the next one we saw, surface area will give me more successful collision, and the unsuccessful who were there, you aided them with additional energy. एक बार और टक्कर मारो ना, एक बार और पूछो ना, शायद हो जाएगा. हाँ, हो गया उसका. So that goes increasing. So I think more than this today, we'll just test some questions.